OpenAMRobot release 0.1. What we have here, laser cut and bent sheet metal as a basic technology to produce the chassis design. As you can see, everything is produced with these two technologies, laser cut and bend. It's easy to assembly. After you bend everything, you can assemble this with rivets and screws. Yes, and all the parts are fitting like this together. Now it's okay. Now we are using this conventional design for wheel and motors, but in next release we plan to use hub motor wheel. Yes, you just need to install it here and that's it. Now you have also turning works here, but this is first release. Yes, prototype, let's say. We use one LiDAR, but it's possible to install two LiDARs. We have also places for infrared and ultrasonic sensors, emergency stop button, camera, currently temporary here, but basically here is the place for depth camera, yes, for auto docking and for better visual odometry. What else? For this, to produce this cover, we use vacuum forming, but also in GitHub you will find the option for laser cut and bending. This is how it looks with the cover, and here you can see a slot for laser, yes, for LiDAR. Then next, this is already for third release. Yes, this is for dual arm robot. This will be a lifting mechanism, so robotic arms will be there, here, and perception module will be here. But this is third release. In this first release, a little bit about electronics and software that we use. By the way, here is a charger. It's still contact charging station, but we still plan to use wireless charging. Yes. In terms of electronics, what we have Raspberry Pi as a central computer, a Tinzi. We have two encoders on the wheels, IMU module, two drivers for BLDC motors. Here now the battery pack is lead acid, but basically you can use any, and in GitHub you will find different options for batteries and chargers. What else we have about software and firmware? Currently real-time firmware is on Tinzi, and of course we plan to improve it significantly in the second release, add more watchdogs, add some safety layers, and we plan to move and to port it to STM32. Right now it's Tinzi again. In terms of ROS-based part, we have simulation in Gazebo, navigation tool stack, ROS2, advanced cool user interface with many things, many let's say tools that you can use to easily program robot to execute any tasks, because it's block-based, also voice-based. You can give voice commands that will be converted to blocks, and you can check if everything is okay and just click. Everything is very well described and documented and placed open source in GitHub. You will see this robot in operations, not right now, but for example in the next video, and maybe you saw it already. This is first version 0.1, and we are moving forward.